did it yesterday. Today we'll do it with MVT. Then after that we'll talk on dynamic memory partitioning technique. Okay. Then we have paging, but paging will not discuss. We'll discuss on deadlocks. So let's take an example. Assume that we are using OS MVT, variable partition technique. MVT is variable partition, and we have batch processes arriving in order. With the following request. For storage. The request is 20 kilo, 30 kilo, 10 kilobytes, 100 kilobytes, 60 kilobytes. Assume that we have 4 holes in memory. Assume that we have 4 holes in memory of size. Okay, size is also given. 50, 30, 200, 50 kilo, 30K, 200K, 16K. $30K. Where would each of the first fit and worst fit algorithm place the processes? Where would each of the first fit and worst fit algorithms place the process? Okay, so now let's solve this. Assume that we are using operating system with variable partition, and we have batch processes arriving in order with the following request for storage. Job 1 is of size, assume that this is job 1, whose size is 20 kilobytes, job 2 30 kilobytes, job 3 10 kilobytes, job 4 100, and job 5. And assume that we have 4 holes in memory of size 50, 30 and 260. So here we'll not take this 30. Assume that we'll have this first 4 holes. Okay. So where would each of the first fit and worst fit algorithms place the processes? So let us assume that we have a memory. Okay. Or we'll think like that. Otherwise, okay. 50 kilobytes. First 50 kilobytes. You assume that it is used by the operating system. Okay, and remaining 30 to 100 kilobytes, 16 and 30 kilobytes are 4 holes which are available in memory, for example. Okay, so Here I have 30 kilobytes, and next I have 200 kilobytes partition. Then I have 16, okay. Then I have 16 kilobytes. Then I have 30 kilobytes. Assume that we are at the beginning of this block. Now using first fit algorithm, okay. Now first request, suppose job 1 is in the queue, job 2 is in the queue, job 3 is in the queue, job 4 is in the queue. When job 1 arrives, okay, now we will see first fit algorithm. In first fit algorithm, okay, I'll name it as partition 1, and I'll name it as partition 2, and I'll name it as partition 3, and I'll name it as partition 4. Okay. Using first fit algorithm, okay, when 20 kilobytes of process comes, then here it will check this condition: is this 20 kilobytes is less than or equal to the size of partition? Yes, it is true. The 20 kilobytes is less than or equal to the size of partition. When it meets, then partition P1 will be allocated for job 1. For job 1, partition P1 will be allocated. But as a result of this, there will be an internal fragmentation. The internal fragmentation would be, the size of the process is 20 kilobytes, but the size of the partition is 30. So 10 kilobytes is of internal fragmentation. So now, after allocating it, again, the pointer will be at starting. The last allocated block here is P1. Okay, the last allocated block here is P1. Now, when job J2 comes, okay, now the size of job J2 is 30 kilobytes. Now here what happens, it will check. Next, first partition, it is already occupied by job 1. Okay. Now when another process comes, okay, when job 2 comes, it will check again this condition: is 200 kilobytes is the size of the process, which is 30 kilobytes less than or equal to 200 kilobytes. Yes, it is true. Then partition P2 will be allocated for it. So as a result of which, the internal fragmentation is, the size of the process is 30 kilobytes, okay, 30 kilobytes, and the size of the partition is 200 kilobytes. So 200 kilo minus 30, it gives you 170 kilobytes of internal fragmentation. So it is considerably very huge, or it's a big memory, internal fragmentation. Now when job J3 arrives, what happens? The size of job 3 is 10 kilobytes. Okay, if the size of job 3 is 10 kilobytes, then it will check, it is filled, it is also filled. Then partition P3 will be allocated. When partition P3 is allocated, then internal fragmentation will be 16 minus 10, which is the size of this job, which leaves in 6 kilobytes. Okay. The next job 4 comes. Okay. When job 4 comes, again it checks. What does it checks? It checks that process P1 is filled, process this is also filled, and job 3, partition P3 is also filled with job 3. Now it has chance to put job J4 in partition P4. But the size of partition P4 is, now here the condition, the size of partition, which is the size of this process, which is 100 kilobytes, okay, is it less than or equal to the size of partition, which is 30 kilobytes? No, this condition is not fails. It gets failed. When it gets failed, then this partition will not be allocated for job J4. Now job J4 has to wait till any one of these jobs gets completed. Okay. Now thereby it results in an external fragmentation of 30 kilobytes. Okay. And similarly, job J5 also cannot be accommodated, because the available space is only 30 kilobytes and the size of the process is 60 kilobytes. So using first fit algorithm, I could able to accommodate only 3 processes in memory, and here the degree of multiprogramming is only 3. Now we'll look with another algorithm and see whether when we change the algorithm, is it affecting on degree of multi-programming or not. So this is how. So total internal fragmentation. So total fragmentation is internal fragmentation plus external fragmentation. Here we have internal fragmentation of 10 plus 170 and plus 6 plus external fragmentation is 30 kilobytes. Okay. So which is equivalent to 186 plus 30, which gives us 216 96. Okay. 216 kilobytes. Now it is when we see job J4 and J5 is not allowed. The total amount of memory they need is 160 kilobytes, but here we have 260 kilobytes of memory which is available. Okay. It means that for this particular request, first fit doesn't gives good performance. Here the utilization of memory is not good. Of course, because we are then the CPU utilization is not good, because the degree of multi-programming is limited to 3 here for this request. Let us see another algorithm and see how this jobs will be allocated in memory. We'll go for worst fit algorithm. Okay, in worst fit algorithm, it tries to get the maximum internal fragmentation. Okay, in worst fit, when 20 kilobytes is job comes, now it will see what is the internal fragmentation for partition P1. If it has been allocated, then the internal fragmentation IF is how much? So 30 minus 20, which is 10. Okay, but if the internal fragmentation, what is the internal fragmentation for partition P2? Okay, now which is 200 minus 20, which is equivalent to 180. Okay, now of course all other values will be lesser than this value. So partition P2 will be selected for job J1. So job J1 will be loaded, and when job J1 is loaded in partition P2, then internal fragmentation is 180 kilobytes KB. Okay, then another job comes which is J2, and the size of this job is 30 kilobytes. Now it will check 30 and 30, total internal fragmentation is 0, but it doesn't allocate it. It will go and look it here, and it will look it here. Okay, so now here it is not possible to accommodate. It doesn't possible accommodate. So whenever we have a tie, then it depends on first come first serve basis. So job J2 will be allocated to this